There are also several features that come with cloud storage. I will cover these at a high level for now because we will soon dive deeper into some of them. Earlier in the course series, we already talked a little bit about customer-supplied encryption keys when attaching persistent disks to virtual machines. This allows you to supply your own encryption keys instead of the Google Managed Keys, which is also available for cloud storage. Cloud storage also provides object lifecycle management, which lets you automatically delete or archive objects. Another feature is object versioning, which allows you to maintain multiple versions of objects in your bucket. You are charged for the versions as if there are multiple files, which is something to keep in mind. Cloud storage also offers directory synchronization so that you can sync a VM directory with a bucket. We will discuss object change notification, data import, and strong consistency in more detail after going into object versioning and object lifecycle management. In cloud storage, objects are immutable, which means that an uploaded object cannot change throughout its storage lifetime. To support the retrieval of objects that are deleted or overwritten, cloud storage offers the object versioning feature. Object versioning can be enabled for a bucket. Once enabled, cloud storage creates an archived version of an object each time the live version of the object is overwritten or deleted. The archived version retains the name of the object, but is uniquely identified by a generation number as illustrated on this slide by G1. When object versioning is enabled, you can list archived versions of an object, restore the live version of an object to an older state, or permanently delete an archived version as needed. You can turn versioning on or off for a bucket at any time. Turning versioning off leaves existing object versions in place and causes the bucket to stop accumulating new archived object versions. For more information on object versioning, refer to the links section of this video. To support common use cases like setting a time to live for objects, archiving older versions of objects, or downgrading storage classes of objects to help manage costs, cloud storage offers object lifecycle management. You can assign a lifecycle management configuration to a bucket. The configuration is a set of rules that apply to all objects in the buckets. So when an object meets the criteria of one of the rules, cloud storage automatically performs a specified action on the object. Here are some example use cases. First, downgrade the storage class of objects older than a year to cold line storage. Second, delete objects created before a specific date, for example, January 1st, 2017. Or third, keep only the 3 most recent versions of each object in a bucket with versioning enabled. Object inspection occurs in asynchronous batches, so rules may not be applied immediately. Also, updates to your lifecycle configuration may take up to 24 hours to go into effect. This means that when you change your lifecycle configuration, object lifecycle management may still perform actions based on the old configuration for up to 24 hours. So keep that in mind. For more on object lifecycle management, refer to the links section of this video. Object change notification can be used to notify an application when an object is updated or added to a bucket through a watch request. Completing a watch request creates a new notification channel. The notification channel is the means by which the notification message is sent to an application watching a bucket. As of this recording, the only type of notification channel supported is a webhook. After a notification channel is initiated, cloud storage notifies the application at any time an object is added, updated, or removed from the bucket. For example, as shown here, when you add a new picture to a bucket, an application can be notified to create a thumbnail. However, PubSub notifications are really the recommended way to track changes to objects in your cloud storage buckets because they're faster, more flexible, easier to set up, and more cost-effective. PubSub is Google's distributed real-time messaging service, which is covered in the Developing Applications courses. The Cloud Console allows you to upload individual files to your bucket. But what if you have to upload terabytes or even petabytes of data? There are 3 services that address this: Transfer Appliance, Storage Transfer Service, and Offline Media Import. Transfer Appliance is a hardware appliance you can use to securely migrate large volumes of data from hundreds of terabytes up to 1 petabyte to Google Cloud without disrupting business operations. The images on this slide are transfer appliances. The storage transfer service enables high-performance imports of online data. The data source can be another cloud storage bucket, an Amazon S3 bucket, or an HTTP/HTTPS location. Finally, offline media import is a third-party service where physical media such as storage arrays, hard disk drives, tapes, and USB flash drives is sent to a provider who uploads the data. For more information on these three services, refer to the link section of this video. When you upload an object to cloud storage and you receive a success response, the object is immediately available for download and metadata operations from any location where Google offers service. This is true whether you create a new object or overwrite an existing object. Because uploads are strongly consistent, you will never receive a 404 not found response or stale data for a read after write or read after metadata update operation. Strong global consistency also extends to the deletion operation of objects. If a deletion request succeeds, an immediate attempt to download the object or its metadata will result in a 404 not found status code. You get the 404 error because the object no longer exists after the delete operation succeeds. Bucket listing is strongly consistent. For example, if you create a bucket, then immediately perform a list bucket operation, the new bucket appears in the returned list of buckets. Finally, object listing is also strongly consistent. For example, if you upload an object to a bucket and then immediately perform a list object operations, the new object appears in the returned list of objects.